And this would mean everything between A and B, including both A and B, right? And then how do we say all real numbers? Everything.
Fancy R.
Negative infinity to infinity. Yes, the fancy R is a proper way to say all real numbers, but in interval notation, it's that. Okay? Do we ever put brackets on infinity? No, because infinity is not a number, right? So, yeah, the graph never stops. There's no stopping point. So, infinity is an idea, right? It's an idea. In fact, in calculus, you'll be asked things like this, like what's infinity plus infinity? Two infinities? No, it's still infinity. It's just infinity. What's infinity divided by infinity? Actually, that's a lot harder. We don't know. You have to investigate what's being divided first. You can't just, there's no quick, easy answer for this. And it goes this way too. What's infinity minus infinity? 0? That's another one we don't know.
You know,
So,
if we're just going to talk about confusing stuff, why not just do infinity divided by 0 while we're at it?
infinity divided by 0 is actually infinity in calculus 1.
No.
Yeah, but look, we're getting ahead of ourselves. I know. Hold on, because hold on. We're getting ahead of ourselves. Any number divided by 0 is undefined. But so this is undefined. But if I have a function that's getting really, really big, and I'm dividing it by a function that's getting really, really small, what happens? It gets really, really big. That's what we'll study in calculus. Let's not get ahead of ourselves. All right. All right. Back to this. How do I represent the domain? Well, it's everything from 1 to 4, including 1, excluding 4, and then everything after 4, right? So here's how I would write the answer to this problem.
You just put a third point in there, putting infinity?
Nope, watch. So from here to here, I'm going to go bracket 1 to 4 parenthesis. And then we use this symbol, U, which stands for the union, which means basically throw those answers together with the following, with another interval. And then you go from 4 on, right? And you go parenthesis 4 all the way forever, infinity, like that. It's very important that you have this union and that you have the 4 is not there, so you have parentheses on both of them. You're taking out that 4. People always ask, like, well, why do you, if you can't go to 4, if you can't include 4, why don't you just write a closed bracket and use the number that's right next to 4 and just put it right there?
Yeah, but that would be 3.9999999.
Is that the number right next to 4? What's the number right to the left of 4? I mean, just like, there's 4, just go right there. What's that first number right there?
3.9 repeating.
3.9 repeating? What do y'all think?
That's what I just said.
No, I'm asking you. Do you think that that's it? I heard you. Do you think that's the number right next to 4?
Decimal, so I assume that's wrong.
We'll take a vote. How many of you think 3.99 is the number forever? 3.9999 forever is the number right next to 4. Okay, how many of you think it is not? And the rest of you don't care, don't have an opinion? Need to think about it some more?
Well, they're both essentially saying the same thing. It's just one shorter than the other.
Is 3.999 shorter than 4?
Yes, sir. Yeah.
I'm just asking you to ponder this, okay? All right, so,
It's small as you
okay. Do you want to know the answer?
I have a feeling we're wrong, but
Well, if this was the number right next to 4, right, if it was, then why wouldn't I just write this, union, and then what would be the number right bigger than 4?
4.0 repeating 1.
4.00000. Hold on, that's, but isn't that just 4?
no.
No? Oh, you mean there's a 1 at the end somewhere? But if you put a 1 at the end, I can find one smaller than that, can I? Like if you ever stop that, I'm going to be able to find one smaller?
Yeah.
Can you do 4.0 repeating 1?
So we're having a very, very deep conversation here, whether or not you understand that we are, okay? Is there a closest number to 4? On this side, is there a closest number? On this side, is there a closest
You're
number?
always going to find a closer number
So you'll always be able to find one closer?
the farther you go out.
This is the way you have to start thinking if you're actually considering engineering, things like these. You have to think about things that seem abstract like this. This is an abstract idea. So you want to know the answer, right? This is the answer to the problem that I just asked, all right? A. But you want to know the answer whether or not there is a number, if 3.99 is closest to 4. Right? Or is 4, sorry. Or is it 4 or closest number? We'll answer the question. Here we go. You ready? I'll convince you of it, hopefully. I'm going to define right now, I'm going to tell everyone in the class right now, x is 0.99. Well, I'll do the 4 since you want me to do the 4. 3.999 forever with the bar, right? Everyone? That's x. All right. Just let me know if you disagree at any point. What's 10x? So what does multiplying something by 10 do to the decimal?
It moves it over 1.
Moves it over which way?
One way to the right.
To the right. So this should be 39.999 forever?
Yep.
Everyone agree with that so far?
Yes.
Yes? Hold on, let me check something real quick.
I just want to estimate it to make it 40 already.
Yeah, this will work. Okay. No one disagrees? We're okay with this?
Yes.
You're questioning whether or not you move the decimal over?
No, it's cool either way.
Okay, so we can keep going? So we have one on the fence here. But everyone else agrees you multiply by 10, decimal goes to the right one place. Okay, now, forget that for a second. Just purely from an algebraic standpoint, what's 10x take away x? Algebraically, what's 10x minus x? 9x. Now I'm doing it vertically for a reason. 10x take away 1x, you're going to get 9x's, right? Now what I'd like for you to do is I'd like for you to take the problem I just gave you and take 10x and subtract x. So what's 10x over here? 39.999 forever, right? Subtract from that x, which is what? 3.999 forever? Yes? Okay, what happens when we subtract these? What about the 0.999s forever? They're all gone, right? All these 9s forever, all these 9s forever, you're subtracting each one of them. These 9s, that end of the problem is gone, isn't it? Yes. And all you're really left with is 39 minus 3, which is? 36. So you told me algebraically that 10x minus x is 9x, but you agreed that if I define x to be this and multiply it by 10, that this was okay. So this minus this should be equivalent to 9x. Those should be the same, which means x is what? 4. 3.999 forever is 4.
That's weird. Now, does it work the same like if you do 4.0 repeating 1?
4.0 forever is 4, but that's a little
No, like with
less
a 1
on.
at the end.
You can't,
That-
because then it can't
do that?
repeat forever.
Okay.
How about, this means that 0.999 forever is what? 1. So that's why we have to use a notation with the parentheses, because you can't ever tell me the closest number to 4. There's always one closer. Interesting, huh? All right, let's look at the next one. Well, yeah, let's look at part B. B, g of x is x cubed minus x squared. Ariel, you gotta like go walk in the hall or something. Because I was jumping John's shit the first day of class, right? For your texting and stuff, remember? So I can't not jump your shit for sleeping in class. You know what I'm saying? So just go walk around if you need to. Just don't be falling asleep. So what's, Ariel, what's 0.9999 forever? See, you're not good.
I swear, you can look at my notes.
What's 0.999 forever, everyone? 1. So, you know, little gaps in there. All right. I know you're just tired today, but I would, like I said, if you're really tired, just go walk around. Just don't fall asleep in here. You know, if you feel yourself falling asleep, just at least go, do some jumping jacks in the hallway or something. All right. What about G? Any problems here? Do you see any even roots?
Yes. Yes.
You do? Roots? Roots.
Sorry.
No roots, right? So no problems? Okay, do you see anywhere where we might get division by 0?
No.
No, I don't see any fractions. So the domain of this, I can plug anything I want into this. All real numbers. So in interval notation, this is correct. But if on a test for all real numbers you want to put that, I won't take off for it. That one's easy, right? How about C? Capital H of x is x over x squared, or sorry, x over x to the 4th plus 1.
Off the top of my head, x cannot equal 1.
X cannot be 1
Or 0,
or 0.
Why can't it be 0?
because you would be divided by 0.
No, you'd be dividing 0 by something.
If I try and plug 0 into this function, I get 0 over 0 to the 4th power plus 1, which is 0 divided by 1. Is it okay to divide some 0 by 1?
Yes.
Yes, it's not okay to divide 1 by 0. So that is okay.
It just can't be 1 because 1 to the 4th power would be. Or, no, it can't be. No? No, there's nothing it can't be. It's all real numbers.
Okay, so we can sit here and we just start looking and plugging in. I think a more systematic approach is better. No, it's all right, because you have to at least first look, right, and see what kind of things are happening. Do we have an even root?
No.
Even
No
root. There's no roots in here, right? Do we have a possibility of division by 0? Yes, we do. So what we need, right, is that x to the 4th plus 1 is not 0. We need to make sure that's true, right? Well, we should make sure that that never happens. Which means that we need to make sure that x to the 4th is never what?
Negative 1.
Negative 1. And what can you tell me right now?
It can't be negative.
That's not going to happen.
Unless you get like imaginary.
Unless we have imaginary numbers, right? X to the 4th power is never going to be negative 1. Now, had this been x cubed, that could happen, right? But there's nothing you can raise to a 4th power and get negative 1. There's just not going to happen. So that means there's no problems, right? There's nothing we have to worry about at all. So what's the domain? All real numbers. Everything again. What if I change this to a minus? Minus, minus, move it over.
Then 1.
Then you would have 1. Then you would have to do even root. And you get plus or minus, and plus or minus 1 would have had to have been thrown out. Yes?
Just a quick question. If you have a negative absolute value like of x, if you had negative 1 absolute value,
Negative 1 absolute value. What about that?
yeah, like wouldn't you still get 1? Wouldn't you get negative 1?
Where, in here, or are you just saying this?
Like for that x squared, like, or do you just assume that it's,
If I took negative 1 absolute value and raised it to the 4th power,
yeah,
well, you would have to first figure out this, which is 1.
okay.
And then to the 4th power is 1 times 1 times 1 times 1.
Oh, but what, like if the negative was outside the absolute? You know,
Negative.
doesn't it make it negative 1? Does it stay negative 1?
I'm not quite sure I'm following you. I have to replace this with a number, right? I think what you're asking me to do is replace it with an absolute value.
I was just curious about it. Like, how does it?
I think he's saying like if you took that, like what you have, like the negative
Like, could
and
you
then the
still
absolute
get a
value
negative
of 1.
Hold on. Let John finish first. So
I was just seeing like if you could still possibly get a negative 1 with.
the only way you're going to get a negative, you could actually make this true, is if you're willing to deal with the imaginary numbers. Because that's the only way, the only time you can ever raise something to an even power and get a negative number is if you have the complex numbers, the imaginary numbers, they're fair game. But right now they're not fair game. There's no other way to do it. Yes?
A risk of sounding dense, how did you come up with the negative 1? How do you know that it can't be a negative 1 x to the 4th?
Okay, what about this? If you square a number, what are you guaranteeing me? If I take any number and square it, the answer's got to be what? Positive. Worst case scenario, it would be 0, because if you square 0, you get 0. But if this is a positive number, you square it's positive. Negative number squared, it's... So just look at x to the fourth as being x squared squared. So this down here is definitely positive. You square it again, it's still positive. This is like overkill squaring. You know what I mean? You know what I'm saying? It's like, not only is this going to work, that'll just do more. So there's no way you're getting negative out of that.
Okay.
And sixth power would be the same. If you do sixth, you could just do that.
So basically you're saying that it can't be a negative number.
Any number raised to an even power cannot be a negative number.
Okay, I
Yep.
just want to make sure that where I was getting the negative one from didn't matter.
That's right. I should restate, any real number raised to an even power cannot be a negative number.
But if it was cubed, then
Cubed, it would work, okay, because what's negative 1 cubed? It's negative 1 times negative 1 times negative 1. The first two together is 1, and then the third one multiplied would give you the negative, so that would work. Okay, let's see. How about D? On D, I use a different variable. Capital T of little t, that's kind of weird, right? Equals square root of t over 9 minus t squared. So let's again try and be a little more systematic about this. Okay? First of all, do we have any roots?
Yes.
Yes. Or is it an even root?
Yes.
Yes.
Yes, it's a square root, right? And what we need to make sure is that the radicand is never negative, which means we need the radicand to be bigger than or equal to 0, right? The radicand, whatever's under here, has to be bigger than or equal to 0. And that's a linear inequality, and it's already solved. Like, there's nothing more for me to do here. T's got to be bigger than or equal to 0. Done. Now I move on to the second thing. Is it possible to get division by 0?
Yes.
Yes, it is. It could happen if, yeah, what we need is that 9 minus t squared cannot be 0, right? What type of equation is this? Even though we're trying to figure out when it's not this, what type of equation is this? Yes, that's how we'll solve it, but it's a quadratic equation, right? So I could do difference of squares, 3 plus t, 3 minus t. Cannot be equal to 0. And then I could split that into two equations, right? And solve each one. And I would get two different things.
So T can't equal positive or negative.
Cannot be plus or minus 3. You could have also moved the t squared over and took the square root on both sides and done plus or minus, and you would have got the same answers. So let's put this information together, all right? On part 1, I'm saying on a number line, I'll do this in blue, this part, that t must be bigger than or equal to 0. So it's everything from 0 to the right, yeah? And then on the second part, I'm saying that you cannot have what? 3, which is over here, right?
Or negative
3, I must take that out. And then negative 3, I must take that out. But yeah, the blue already told me I couldn't be over here. So the answer is what these two things have in common, right? Which would be what? It's that stuff in black, right? It's just the stuff to the right of 0 till I get to 3, skip over it, keep going forever. So go ahead.
Bracket.
Jacob, or who said?
Bracket
Jacob was going.
0,
Bracket 0,
comma, 3,
3,
parentheses,
parenthesis,
U,
union,
parentheses, 3, comma, infinity,
parenthesis. That's it. That's your domain. As long as you pick a number from there, this function's in business. If you pick a number that's not in there, the function's going to fall apart. All right, let's look at this last I'm gonna skip E. I'm gonna go to F. F's the most complicated one up there, and probably the one that's the type of problem that I like to ask on a test. Something like F. F of x is the square root of 2x squared plus 9x plus 4. Okay, so we have really only one thing to worry about. It's the radicand, right? Yeah. That radicand has to be bigger than or equal to 0. So I'm only have the issue for one. One of the things that we like to avoid. This right here has to be greater than or equal to 0. I know, Ariel, I know you're tired. I know that everyone else, we're at the end of class here, but this is very important that you understand how to solve this, okay? I don't know how many times I've given this problem on the test, and half the class does it the way they think it's supposed to be done. It's wrong, and they get taken off, you know, major points. All right, so we all good? We're going to ask questions if you have them. Okay, this is called a quadratic inequality. It's not a quadratic equation because it's an inequality. And there is a process to actually figure out how to solve this. And it is not as easy as a quadratic equation is to solve. Right? So we call this a quadratic inequality.
Would you still start by factoring it?
Almost. What we do to start, and this is what I like to see when I'm looking at your test, what you do is you first convert it to an equation. All right? So we're going to change it. It's an inequality right now. I'm going to switch it. I'm going to make it an equation. I'm going to do that because I actually know how to solve quadratic equations. And part of this inequality says that I can be equal to 0. So I may as well figure out when that happens. Right? This is not helping me figure out when I'm bigger than 0, just when I'm equal to 0. Right? Yes. So we solve this. So I don't know, maybe it factors. Does it? Yes. I think it does. Right? 4.
Yeah, it does.
1. Is that right? So you get these two solutions. X should be negative a half, and the other one is x is negative 4. So that, pretty straightforward, right? And that's what a lot of people will do on a test, and then from here they just totally drop the ball. What you need to do now is you need to come back and maybe try and visualize the number line of what your answers represent. Remember how we've been doing the number line, trying to figure out what goes, you know, what stays, what doesn't? Right now, what I know is that negative 1/2 and 4 can both be there, right? Oops. Thank you. Right, those two numbers are good to go, right? They're part of my answer. They're in the domain. What remains to be seen is whether or not I'm going to include stuff from here to the left of negative 4, if I'm going to include stuff between negative 4 and negative 1/2, or if I'm going to include stuff over here. We don't know. So the way we actually figure it out is we just check. We just test some points. That's all we have to do. Just pick any number you want over here and tell me whether or not this is true or not. So if someone give me a number to the left of negative 4. I'm going to mark it with a little x because I don't want you to think it's part of my answers. Negative 12? Fine. It's fine. And then plug it into here. Is it true or not? So that means you have to do 2 times negative 12 squared plus 9 times negative 12 plus 4. And you're asking yourself, is that bigger than or equal to 0? So what's 12 squared? 144 times 2? 288. Minus? Minus 108? Plus 4? Is that bigger than or equal to 0? Yes. Right? It's a positive number? We clear? That means everything over here to the left of -4 works. That means everything over here is good to go. All you have to do is check one point.
Okay.
Yeah, we couldn't say, okay, now go check this. I mean, you'd be
Okay,
here for
so
the rest of
you're-
your life, right?
So you just check for the individual areas then?
Yes, what we do is we look at this as like these two numbers that we knew were there, they partition the number line into 3 regions. And I'm picking a test point from each region. All right? So let's pick a nice test point in here. -2, -1. I like -1. It's easier to square and multiply. So let's plug -1 into this again. So 2 times -1 squared plus 9 times -1 plus 4. Is that bigger than or equal to 0? Question. It is not. This turns out to be a negative number on the left side. So that's not true, which means that I do not include anything in here, so I'm not going to fill it in. And then you check another point, something to the right of -1/2, which would be 1's good, 0's good. 0's the best. I love 0. 0's so fun to test, isn't it? Because you just plug it in right here, it just kills it, and then you're left with 4. 4 is bigger than 0. Check. Yes. That means everything this way forever. And so your answer is, in interval notation, how do we say negative infinity? -4 brackets. So that gives you everything that way, right?
Yes.
And then union, -1/2. And then there. That's everything. That's it. That's it right there.
I guess it's just to make sure that you carry it on and not just, oh, well, this is it.
Well, here's what a lot of people do, okay? I hate putting the wrong thing on the board, but here's what a lot of people do. They'll look at this, they'll say, oh, okay, sure, and then they start factoring right now. What was it? Right, like that. And then they set each of these greater than or equal to 0. So they get like 2x plus 1 greater than or equal to 0, and then the other one, x plus 4 greater than or equal to 0. And so this answer right here, if you move the 1 over, divide by 2, you get x is greater than or equal to -1/2. And this one over here, you get x is greater than or equal to -4. Understand what I did here?
Yes.
This is all incorrect. But someone's going to do this on the test. Any volunteers? Who's going to volunteer to do that?
Okay,
No?
because then it would change the whole part.
Watch, look at the answer that you would get if you did it this way. Look at your number line. -4, -1/2. According to you, right? According to you, everything bigger than -1/2, including -1/2 works, right? And everything bigger than or equal to -4, which means -4 and everything which way? To the right. Well, guess what? We already know. We checked some points ourselves, right? We knew that numbers over here worked. -12 worked. In fact, we checked in here, -1 didn't work. But according to you, it does. This is so wrong that it's penalized pretty heavily on a test. I don't care that you can factor. What I care about is whether or not you can solve a quadratic inequality properly. Clear? Yes?
Okay, so you factor them equal to a number, like preferably 0. I would
Yeah.
assume, and then plug those in for the inequality.
Yep, so to solve a quadratic inequality, you move everything to one side, you make it an equation. Solve the equation, plot those points on a number line, test the individual regions, and you're done. How are we doing? Man. I think I'm going to glaze over this, adding and subtracting, multiplying, dividing. I think I'm going to get into that. I'll come back and address that next class if I need to. What I want to get you to look at right now in the last 10 minutes of class is what's called the difference quotient. Now, just by a show of hands, any of you heard that before, difference quotient? It's been a while, okay.
It's been about 6 years.
The difference quotient is fundamental to your success in Calculus 1, all right? The difference quotient is the following. F of x plus h minus f of x over h. That's called the difference quotient.
That specific equation
That specific expression,
or expression. Sorry.
okay? What this expression assumes is a few things. First of all, h can't be 0. Now, why can't h be 0? You're dividing by 0, and we're not allowed to do that, right? And then it's assuming that there's some function out there, right? So if somebody gives you a function, f of x is x squared, f of x is, whatever they want to give you, if I hand you a function, you should be able to compute this. Do you recognize that the top left corner of this is part f of the problem we did earlier? It's plugging x plus h into some function.
Yeah.
The top right corner of this is just the function itself. Yeah? And then divided by h and subtract and divide by h. You have to be able to compute this by hand, algebraically, or else calculus will be a disaster for you. And since I only have 8 minutes left, what I want to do right now is I want to show you where it comes from, why it's important, why we need it. Like, what is that, right? What is this thing? So let me try and motivate that idea real quick. And I'm going to give you an example that hopefully will be something you can relate to. Let's say that we have some axis that represents time, and let's say that's in hours. And let's say we have another axis which is distance, and let's say that's measured in miles. And the example I'm showing here is you're going to get up, you're going to get in your car, and you're going to drive to work or drive to school or whatever it is, right? Or maybe you're going to make a trip across Texas somewhere. Whatever, you get in your car. As soon as you get in your car and you're about to start moving, you start the clock, all right? You're driving along. And then eventually, after a certain amount of time, let's just say after 4 hours of driving, you have gone, let's say, 160 miles. All right? First question, what is your average speed?
40 miles per hour.
40 miles per hour. How are you getting that?
Divided by 4.
Okay, you're taking 160 dividing by 4. But geometrically, what you're actually doing is you're connecting this point, the ending point to the starting point, and you're creating a line. And you're finding the slope of that line. Because what is the slope of this line? Slope, remember, was rise over run. And the rise in this case would be how much? 160, right? And then the run would be how far, or this distance, right? Your change in x, which would be 4, which is was what you told me a second ago, right? This was what? 40? What was the unit of measurement for the rise? What was the 160 a measurement of? Miles. And I'm dividing that by the 4, which was a unit measurement of time. So this is miles per hour, isn't it?
Yes.
Miles per hour. Right? So we could all, I think, look at that and say, obviously we were going 40 miles per hour. But what's more important is that you understand the 40 miles per hour also corresponds to the slope of the line connecting these 2 points. So now if I come in here and I change the question, and I say, all right, what was your average speed on the whole trip? Instead of that, I'm only interested in knowing between the first hour and second hour, what was your average speed? So now that's from this point to this point, right? If you could tell me the slope of that line, you could tell me your average speed, couldn't you? But I would have to know how far you had gone at 2 hours and at 1 hour, right? I'd have to know the 2 y values in order for me to answer the question. But you understand what I'm asking? Okay, and then let's say, I don't want to erase and keep on going over that. Let's say instead of asking you that, I say, I'm not interested in the first hour, between the first hour and second hour. I'm interested in the first hour and 1.5 hours, which would be, again, 2 points, right? Need the slope of that line. Could we do it if we knew the values? Yes? And that would be a smaller increment of time, right? It would be a smaller little segment on here. And then I come in and I ask you, you know what, I'm not interested in your average speed between 1 and 1.5. I'm interested between 1 and really close, 1.1 hours. That'd be an even smaller one, right? And you just find the slope. And then I say, you know what, I keep on asking you about, you know, your average speed between the first, second hour and first and 1.5 and first and 1.1. Well, shit, what was your speed at 1 hour? Just at 1 hour, how fast were you going? What's wrong?
You don't know.
Well, I don't know, right?
Because you don't know the individual points.
What's wrong with asking about the speed of something at a single point? What did we need to find the speed? Rise over run. If you're at a single point, how much have you gone up by? Right? If I say, okay, come over here, right there, okay? Look at that point, everyone. How much have you gone up by? You'd probably think I'm crazy, and you're like, I haven't gone anywhere, right? How much have I gone up by? How much time has gone by? None, right? So this actually doesn't make sense because it turns into this, doesn't it? 0 over 0. Understand kind of the geometry here? So let me erase this and show you a more general picture, same concept. See if I can do this in 1.5 minutes. Let's take some function, which I'm going to call f. Let's take some point in time, which I'm going to call x. Let's take some other point in time, which I'm going to call, well, it needs to be bigger than x, right? I could do x plus 1, that would be bigger, right? How about if instead I say x plus h, which is x plus something? H might be 1, h might be 2, h might be 0.5, yeah? But it would be a point to the right. Then I come up here and I try and find the point on here. If I can find the slope of the line between these, it would represent the speed between those 2 points in time, wouldn't it? Let's talk about that. What is it? Give me the actual formula for it. So let's see here. It would be rise over run, right? So what would my rise be? The difference in the y's, right? Okay, so let's talk about the y coordinates. I'm going to look at this point here. What's the x coordinate of this point? X. What's the y coordinate? It's whatever I get when I plug x into the function, right? Which I'm just going to call f of x. Do you agree that's what it is? I mean, I don't know what it is because I don't even know what this function is. But it's whatever you get when you plug x into the function. Now what about this point? What are the coordinates of that point? What's the x coordinate? X plus h. What's the y coordinate? F of x plus h, right? Understand? So, if I ask you for rise over run, what's the difference in the y coordinates? It's this one, take away this one, right? Do y'all see that or not? Okay, over the run, which is the difference in the y coordinates, which is this one minus this one, which would be x plus h, take away what? X, and what happens to the x's? They cancel and you're left with just h. What is this called? This is the difference quotient. Why is it valuable? Because what we do in calculus is we say, I want this point here to get closer to this point. I actually want to put that point right on top of that point. And in that case, I would find the slope right at that point, which would be equivalent to the speed at an instant in time, which we call a tangent line, the slope of the tangent line. To do that, though, I have to move this point this way. So how do I move this point this way? You let h get smaller, eventually trying to let h go to 0. And that's, you study in calculus this thing called the limit, and you let h go to 0. But before you can do any of that, you must be able to algebraically figure out what the hell this is. You have to be able to do the algebra in here before you can start doing any of the calculus. But I wanted you to see here, because we're out of time, that this formula is not just some formula sitting there. I mean, like, there's a picture that goes with it. There's a meaning. There's a reason we do it. I'm going to have to call attendance. I've already kept you late. If you want to pick up your assessment packs, they're here. Just say, here or not. I'm going to start from the bottom, because people at the bottom always get screwed. Stephen is here. That's you? Sean, okay. Jacob?
Yep.
Rogelio. That's right. I'm actually getting to see Eric, okay. Maggie? No? Sandra? Chloe? Christopher? Reyes? Abigail? Abby? Right? That's what you prefer? Okay. Robert Ramos? Robert Ramos, no? Robert Pike? Draco? Right. Yeah, I said that. Yeah. Daniel Patrick. Jose? Okay. Jonathan Ortiz? Jason Luna? Caleb? Lindsay? Christopher Diaz? Joseph De Hoyas? Isaac Chapa? Joshua? Adrian? Ryan? Ariel? And Valerie. That's it. You can go. Make sure you start your homework for 3-1, okay? We're not quite done with this section, though. Let me turn my thing off and then